Hey, this is John here, and we are going to do bubble sort in Python. Let's make an array here of data and make it nice and simple. Alright, so with bubble sort, what we're going to do is we're going to walk through the array, and then we're going to compare each element to the rest of the array. So let's compare 3 to 2, and 3 to 5, and 3 to 4, and we're basically going to see any time that the thing being compared to is less than this, we want to swap positions so that the smallest elements bubble up to the front of this array. So let's define our function. It's going to take one argument in the array. So we're going to loop through the array with an outer and an inner loop. I like to have I for my outer loop, so for I in the range from 0 to the length of the array, and then the inner loop will go for j in the range. Now we're going to start at I for the inner loop. We don't need to go all the way back to the beginning because then we'd be comparing to an already sorted part of the array. So we're going to start at the element after I plus 1, and we'll go to the length of the array. So let's just do a check to make sure that we got this right. Let's print I and j, just for a sanity check that we're doing this right. So, oops. Let's call our bubble sort on our data and see what we get here. Okay, so we have I equals 0, j equals 1, 0, 2, 0, 3. So we have I, when I is 0, then we do I equals, j equals 1, 2, and 3. And then when we go to the next outer iteration, we have I equals 1, j equals 2, and 3. And then finally, I equals 2, and j equals 3. So that looks right. So now we just need to do our comparison. If the array at j is less than the array at I, then we want to swap. So we can do that simultaneously here. Arrays of I and array at j will be equal to array at j and array at I. So the thing at j goes into the I position, and the thing at I goes into the j position. And finally, we can return that array for convenience. So now we can print our sorted list. Let's try it out. There we go, 2, 3, 4, 5. Let's try some boundary conditions. Let's do an empty array. That works. An array with one element, that's fine. An array with 2 elements, that works. Here we have an array with 3 elements and then backwards. That works. Let's do 1, 2, 3, try it on a sorted array. Okay, that works. So we can be satisfied that our sorting algorithm works, the bubble sort. And since we're comparing each element to every other element, that is an n squared time complexity. So let's go n squared for time complexity, because as this array grows longer, our number of operations is going to grow as the square. And anytime you have this outer loop and an inner loop, you're essentially cross multiplying. You're multiplying the lengths of these two times each other, and they're both based on the length of our input array, so that's going to be the order n squared. So this is not a good algorithm if you have lots and lots of data. For space complexity, everything is rearranged within the same memory, so it's fine for space. It's order n for space, so that's okay. So I'd say if you know that you're going to be dealing with small amounts of data, small lists here, then this algorithm is fine. You know exactly how long it's going to take to run. It's deterministic in that sense, and it doesn't waste any space. So if you're doing some kind of embedded work or just happen to have really small data, then this works just fine. Alright, thanks for watching.